Okay, hello everyone. So now it's gonna be my part. I think I just want to adjust myself. Okay, first day. Very glad to see everyone. I will talk a little bit about the geomodeling part. So if you look at this course, it's basically more or less you can see it as two segments. One is about the geocomputation. Giuseppe has already mentioned a lot using the open source tools and the Linux environment to perform high volume big data computation analysis. And the other part is about modeling, basically how to use this data you have collected and build a model to your interest. So I'll more or less focus on this modeling part and enjoy this journey together with you. So today is our first course, first time we see each other. So I just built some simple activities so that we can know each other better. And of course, there's a little some access along the course so that I can understand a little better your background. So first of all, Giuseppe already mentioned the class survey. I just want to fish out a few things that I feel that's highly important and highly interesting me. So basically, the way I look at modeling, you need several things at hand to help you become a good modeler. You need to know how to programming. I notice many of you, I mean, all of you are programmers. You have experience with intermediate or advanced level script languages. And that's a really good sign. And also you have some mathematical background. So this is basically very good thing here. I see most of you have done calculus and linear algebra. Not everyone have done probability and statistical inference, but if you have a linear algebra as your backbone, then everything is more or less fall in line with matrix operations. This is very easy. Machine learning, yeah, I will cover that. It's quite really simple once you have the mathematical background. So that's really exciting. Once again, during the break in the police part, when Giuseppe was not there, I talk about this philosophic view about the surroundings, the three worlds, the mathematical world, the physical world, and the emotional world. So I have seen this class as a very good opportunity for us to bring together and make a union of these three words. You have your own interest, a lot of things you want to learn from these classes. Giuseppe and I will try our best to fit in whatever is possible. Some of them are already in the agenda. Giuseppe covered more or less some of them. Some may not, but we'll try to see if they fit in by building a thematic topic or some other means. So overall, it's you. So this class is about you. We want to do this class so that you can maximize the output from this class. And the way to do it is building an interactive interaction between us. So that's the one I talk about, the emotion world, where we talk to each other, we interact with each other, and we learn and grow together. So I just want to stress a little bit about this real world, and it's very important to me because I think in the end of the day, we are all doing nothing but two things. One is a philosophy, the other one is a psychology. So the philosophy thing is very closely related to modeling, because to be a good modeler, you probably have to be a good philosopher in the first hand. And to do the philosophy, I really like this analogy put up by this mathematician from Oxford University. So the process modeling, it's pretty much the elevation from the physical observation of a physical world and transform it into a mathematical representation. And the prediction process is basically using the mathematical presentation to predict what the outcome will be. Of course, there are some built-in assumptions in it. We will talk about later as we move on the courses. So that's why I want to bring up up in the very front that modeling is really heavy on your understanding the mathematical background. With your background, I think we are quite good in our starting point. So something about me, I already mentioned. I'm a modeler, I'm a programmer, I'm a Unix enthusiast. Why I'm interested in modeling? Well, there are several reasons. So I'll start with a little bit of history. So in 340 BC, Aristotle already knew the earth is round. He mentioned that in his book about heavens. So the reason he thinks the world the earth is round, because he observed the moving of the earth when it's coming in between the moving of the moon coming in between the sun and the earth. He found the projection of the earth onto the moon is always ecliptic, which means it's elongated disk instead of a round circle. So based on this observation, he concluded the earth must be round, or in other words, it's a sphere. Okay, I make it again. Okay, so we have 3 planets here. There's a sun, there's the earth, and there's a moon. They are rotating according to their trajectories. And at some point, they will align each other, right? Because it's a well-known phenomenon. And sometimes the earth come in between the moon and the sun. And you can observe the shape of this earth on the moon. And based on his observation, he saw this one's always it's always elliptic, and he concluded that means the Earth is round. It's not a flat surface. Does it make any sense to you? I want to have some reaction here. I just described an observation made by an old people, 340 BC. And he observed this one, and he told us, the Earth is round. Should we believe him? Anybody? Geographers, please say something. Nobody wants to say something?
Well, I mean, we know the Earth is round, like we know that.
I know, yes, okay.
But it's amazing that, I mean, it's such a simple observation actually to think that yes, actually what did you say? The trajectory is elliptic, and it's not I mean, I never thought about it that way and said like this. Of course, it just makes sense. Yeah, I didn't know that. Aristotle already knew that.
Okay, well, thank you so much for your comment. Yes, so we kind of took it as a granted that the Earth is a sphere because we don't think too much about it. But just going back, the reason I bring up this example here is trying to think along with you about this logic reasoning. So it's very important you see the modern process. So even in back then, 340 BC, when there was no telescope or anything, we can really direct observe the shape of the universe. Of course, we are on the Earth, we cannot observe the Earth directly. But through some indirect observations and the logic reasoning, we can derive this conclusion: the Earth is sphere. The reason it's sphere is because if you imagine this Earth is kind of a flat disk, so what kind of shape on the moon would be? It'd be round. So because the sun is rotating, it's rotating in different angles. Because there's not the same position, that's why the shape of the Earth on the moon is elongated on average. But if it's a round disk, then you'll have a round surface on the moon. So that's a simple logic and a simple thinking. So I'll leave it for you to digest, and when you have time, just have some fun, because I like fun stuff. I like tell jokes. The simple things for your side, I just laugh. That's all I want to do. Yeah, so I'm interested in this. And of course, nowadays we know the Earth is a ball with a sphere with we know the diameters, in different dimensions. And why I'm interested in geoscience? I mentioned to you that my background was in quantum chemistry. The people who does quantum like to understand basic things. I like to investigate the fundamental questions, like whether the universe has a beginning in time, whether the universe is limited by space. So basically, I'm interested in space and time. And as we all know, there's no space and time. There's only space time. So I think the geography or geoscience is a special area that I view that connects both space and time, and we can model the spatial temporal process. So that's my strong interest coming here. And I knew you have your own interest to study this course. So I'm really interested in building this course together to the best benefit of your interest. And of course, through the course, I think we know each other better and we learn from each other. So now we talk about the Earth is around is a ball, is a curved, it's a sphere. So I want to throw a question just to activate some neural energy from your brains. So I want to calculate the distance between 2 points on the surface of the Earth. Does anybody know how to do this? Okay, just be clear that we don't use tape measure, just on computer. So it's a far distance. Let's say you want to calculate distance between Stockholm and somewhere else. We're a little far. Yeah, Johnsonburg in South Africa. So let's talk about this kind of level of scale. How do you calculate the distance between the 2 points on the surface of Earth? I'm pretty sure we have done it in the GIS class.
You can use a third object like the moon, calculate the angle between where you are and where you see the moon on the sky, and then use trigonometry to calculate the difference, the distance between point A and point B.
Well, that's a great answer, but you'll probably have to wait for some special period of time to calculate that distance, right? That's a fantastic answer. Anything else? Can we do it on Earth?
I believe if we use coordinates of a special reference ellipsoid or shape that we round up the Earth mass, that is it, then also we can use trigonometry based on, like, once we have fixed the 2 points in 2 coordinates.
Sure, that's what I'm looking for. But what kind of geometry?
So I'm not really sure on how the formula work out in trigonometry.
Well, trigonometry, you're basically talking about Euclidean space, right? That's been worked out by the Greek mathematician Euclideans. But here we're talking about surface.
Yeah.
So you're very close. It's about geometry, but it's a non-Euclidean geometry.
Yeah.
So it's on the surface. So it's basically you have a formula you can calculate difference on the distance on the surface. The formula is very much look like a cosine rule you learn in the trigonometry, but here you have to do a little variation to consider the curvature of the Earth. Oh, very good. I think we are very, very close. We know what we're doing. So that's an entertaining part. So where I'm going from here? Yes. So I'm going to talk about GIS. As we all know, any good course, we start with history, right? And this one is probably very much less known. GIS, it all begins with John Snow and his map. So actually, it's not the John Snow, it's the other John Snow, who studied the chloride spread in Britain and map out the human dynamics and figure out the source of this particular phenomenon. I think you have learned that in GIS class already, but I just want to throw some appetizer in the beginning. What is more important, of course, is later on the applications. At the moment, we are in the situation of a corona pandemic. people are using the GIS technology to map out the cases occurring in the world and try to identify policies so that we can best contain these viruses. This is a particular widely applied application of using GIS modeling. And along this course, in this particular example, we talk about how to limit the mobility of people and trying to achieve the purpose to reduce the likelihood of spread of viruses. Now, speaking of limit, I want to throw in another example, which I'm showing here, which is Siri. So series is a basic mathematical concept. Anybody can help me? What does a series mean? In the mathematical concept, what's a series? Yeah, it's actually written here. So if you look at the equation on the right-hand side, it's a sequence numbers, right? 1, 1/2, 1/3, 1/4, and etc. So these sequence numbers without plus sign is called a sequence. It's a mathematical sequence. And series basically a term invented by Gaussian. He said, okay, if I add up all these numbers individually, which is take the summation of the individual members in the sequence, I call it series. Just a basic concept, doesn't really matter. What it matters is to calculate this summation of the sequences. The example I'm giving here, if I have a sequence shown on the right-hand side, connect them by the plus sign, which gave a sequence, it gave a series. So if I want to calculate the numerical value when this sequence is reaching to infinity, what do I arrive? I gave you two options, 2 or infinity. Think. Whoever have ideas, let me know. This is a well-defined mathematical question. It's not about moon shape, other things.
I think it's
You have
true.
time. It's 2. Why is 2?
Because like the things that I'm summing up is going lower and lower, and in the long run, it's going to be infinitively close to 0.
Yes, you're right. It's going lower and lower, becoming infinite to 0. But what I'm asking is the summation of all these terms, right? It's not when it's one. So there's a distinction here between you look at the individual elements here as a sequence versus the summation of the infinite number of elements. So although each individual member is getting smaller and smaller, but my argument is I have infinite number of items or members in this sequence. So even though each member is very, very small, but I add up infinite number of times, how do you guarantee that's also small?
That like my response was based on the idea that these two things is not going to go together. Like if I put these two things, like I'm putting infinite number, but they're always became lower. I believe as a starting response, I will say 2, but then I will have to try out.
Yeah, you can have a piece of paper or something write down in terms of derive. If you have some proof, please share a screen. I'm happy to see your result. How do you arrive at this result? Sometimes our thinking is impacted by our mental picture, but when you really put down the numbers on the paper, you'll see something different. So I'll tell you first, the answer is infinity. Anybody would like to give a try? Anybody to think how are we going to think about this particular problem? Maybe just some ideas. You don't have to write down details, some ideas.
the classical idea is to you truncate that sum, and then you take two truncations, and then you take the difference. I mean, if this series is convergent, the difference should converge to 0. Otherwise, it is not convergent. Yeah, so that's the classical trick.
Yeah. I'll take that one. So more or less, you look at the sequence right here, right? You can you can take a truncate, or you take part of it. For example, here I take one, then one, you can partition this one into small segments and make them a number that's greater than part of it, like the 1/2. You can partition this 1/2 to 2/2, 3/2, 4/2 together, become a number that's greater than 1/2. Then you can do infinite times, and as you move on, then the summation of each individual term is greater than a definite number. Then the overall limit is infinite. So I didn't show a solution here because I thought it's something we can conquer together. But anyway, it's a very good example to entertain. But now I'm going to crank up the situation a little. One further step is a very famous. It's Leonardo Euler, which is a famous mathematician who have a lot of formulas in your geography, Euler formula, many things. And he proposed his famous Euler theories, which is shown here. A particular representation as a summation of this kind of form. Then he came up with the idea that, okay, if I apply this condition when s equals to -1, I'm sorry, n equal to -1. It should be n. This is a typo. It should be n equal to -1. What I can arrive is I can rewrite this formula into the presentation and arrive the final result to -1/12. So look at it carefully. So what Euler is basically claiming is the summation of all natural numbers, all positive, and the final result is -1/12. And I'm going to show you the proof for this one. So given this particular formula is known, it's true, if you trust me for a moment, we can put in the number -1 here. On the left-hand side, you got 1/4 minus. Then you just plug -1 into the right-hand side, you got this simple representation. I think everybody can do it. Then, like what I already mentioned before, we just do some partition here. So I group the odd number and even number differently. Then I see the odd number, I can just plug in even numbers to make this particular one in the parentheses become the entire summation of natural numbers. Of course, this is minus sign. Pay attention here. I minus this sequence with all the even numbers. Then to make this equation still holds, I have to add back all these even numbers which was being subtracted from here. So apparently, that means when I add 2, that means the original 2 has to be times 2. When I did 4, sorry, there's a 3 missing here. I did 4, then that means I add another 4. Just 4 has 2 times 2, then extra, etc. So basically, this first term is a summation of all the natural numbers, which is minus sign. The other one is the summation of all natural numbers by 4 times. You see here, this is 2 times 2 then equals to 4. 4 times 2 times equals 8. Basically, it's 1 times 4, 2 times 4, 3 times 4. So that means the summation of this equation here on this row gave me 3 times of the summation of all natural numbers. Then I divide 3 on both sides. I see, okay, the summation of all natural numbers is -1/12. Does it make any sense? But it doesn't seem to make any sense to people who does mathematics, right? Because it's all natural numbers is all positive, and my result is -1/12. Is that interesting? And actually, this is a proof given by Leonardo Euler. It's a real historical story. Anybody want to give an attempt here?
You are adding to infinite numbers with opposite signs. That doesn't work.
This one, you say this one is not working? No, it should work. You can give a try. You can add up infinite numbers. That's okay. Why do you think it doesn't work?
The first one is a minus infinity, and the other one is also plus infinity. So you get plus infinity minus infinity.
Yes.
And that's an indeterminate, so you cannot obtain that.
Yeah, I see what you're saying, but okay, but I'm pretty sure we all know about the calculus. Even the infinities, they have different speed to approach this. How fast this infinity is being approached, right? So in this particular instance, I think this operation is okay, because what it happens is just keeping added numbers. You have infinite number here. I can break up into the infinite odd number, infinite even number. So that's actually the truth, right? If you look at the total number of natural numbers, it's infinite, but the total number of all numbers is also infinite. The total number of even numbers is also infinite. And we know the composition of the natural numbers can be divided by odd number and even number. We sum up. So in this case, we basically sum up the infinite number of odd numbers and infinite number of even numbers. We arrive at infinite number of natural numbers. I think this operation is okay.
I think you have to go back to the original expansion. That's not exact when x is
this one.
The first one. Yeah. The expansion x divided by 1 minus x squared.
Yeah, so that's actually that's the core of the question. So that's the core of the question. I wouldn't go into this. You can Google up to look at the convergence radius for this series. That's basically the core part of this problem. But actually, this solution is kind of it's not correct by this one, but in the end, this one leads to Riemann geometry, which is a very interesting observation. Based on some expansion on the domains, the result ended up to 1/12 because this solution was given by Euler. But anyway, there's an interesting story. You can go up. The reason I put it here because many times we make mistakes here and there. More or less, the core of mistakes coming from the very basis, and here it coming from here. All right. So that's about the fun part of some series. We plot. We can use the GIS to analyze the viruses and the air traffic, of course, associated with the transmission of viruses, the shipping, all these migrations. So we have to now, in many countries, are limiting the domain of the traffic of all these mobile actions. And domain is also one important question in mathematics. And I'm going to use an example to illustrate this one. So yes. So my goal is to trying to solve an equation, which is x squared plus x equal to 1. This is equation 1. So I will find out the solution for x squared. This is my goal. And everything below is my approach to solve this problem. So step 1, I see, okay, when x equals 0, it's not a solution. That means x is not equal to 0. Fine. Then I can divide the first equation by x. We arrive at equation 2. It's very easy. X squared divided by x, you get x. X divided by x, 1 over x. 1 divided by x, 1 over x, and x divided by x is 1. So this is equation 2. Now I look at this equation 1, 2. They have some common terms. 1, x, x. So I take the first one minus second one. I arrive at equation 3. right? It's x squared minus 1 over x. This is the basic algebra operations. As already mentioned before, this x is not 0. So I can multiply both ends by x. I arrive at x cubic minus 1 equals 0. Oh, that solution is easy. X equal to 1. So by this point, I take this solution x to 1 back to the original equation. 1 squared is 1, x is 1, and plus 1 equal to 0. And I arrive at a conclusion like highlighted in yellow, which is 3 equal to 0. So what's the problem with this one?
You have used the same equation twice.
I use same equation too much. Anybody else? Somebody else give a chance to look at the problem? Go ahead.
Yeah, I think the part that you subtracted two equations, these two equations are dependent. I think we cannot do these things with dependent
Which
equations.
one? Can you name the equation number? 2, 3?
The equation number 1 and 2. You subtracted these two, and you got the equation 3.
Yeah. Why I cannot do that? What's the problem?
Because I think they are dependent equations. I mean,
yeah, they are okay. They are related. Yeah, we can do it.
So you can reach to one equation by multiplying something to the other equation. So in these cases, we cannot solve a system of equation. You can solve a system of equation. Yeah.
Yes. We cannot solve systematic equations. Agree. But my goal is not to solve the system equation 1, 2, 3. I'm trying to solve one equation. So when I derive equation 2 for x2, then I use 1 minus 2 to derive 3. Then my equations become 3. So that's my interest. So I throw away 1 and 2. I don't look at it. I fully agree with you. You cannot solve a simultaneous equation for this 1, 2, 3. That's true. But I'm not doing that. I think this question is very simple, right? We all know how to do this kind of calculations, but somehow it seems to be the mistake is more or less hidden somewhere. This is a quadratic equation, right? We know from high school even how to solve quadratic equations, right? So if you look at here, there's a real root formula to get the quadratic equations. If you plug in this number here, you find they have 3 solutions. No, the solutions is b squared minus 4ac. So b squared is 1 minus 4 is minus 4. So it's square root minus 4, which means this solution by itself in the beginning, as I wrote here, does not have real roots. So what I did is I solved this problem. I solved solution x cubed minus 1. So if you project this one in the solution space, of course, this one has 3 solutions. You can see clearly. One happened to be 1, the other 2 in the complex domain. So what happens here? The mistake is during the process of operations, I transform the original equation into a different one. And that could be okay if these 2 equations live in the same domain, but actually they don't. One lives in the real domain, one lives in the complex domain. But okay, I can also say this in the complex domain, but it doesn't have a solution in the real space where I claim. All right. Okay, so let's finish this part and continue some interesting questions. So I knew many of you mentioned your strong interest in machine learning, right? Basically, what it's doing in machine learning is you have some observations, which is X, from I mean not the some environmental variables, layers about climate, about temperature, about precipitation, elevation, all the things that come from the geospace. Then you collect some data, some so-called observations. It could be species distributions, the forest fire, or human mobility, many others. And you want to build a correlation between this X and the Y. So you try to look for this function. And this is pretty much a simplified version of representing machine learning. So in the machine learning process, basically, I use a loss function to minimize the difference between the outcome based on the function I constructed, the machine learning function f, and the real observed result, which we take it as truth. You collect from the field data. And based on here, you can make projection. You can make a prediction. You split data in the training and testing. That's a general procedure. And I have done some work before with Giuseppe to predict the distribution of chemical nutrients, nitrogen and phosphorus, in the streams across the United States, of course, continuous in the United States. And in this paper, we talk a little bit about the machine learning technology called random forest. We assess the errors, we analyze the uncertainty, we evaluate the model. In this case, if you have interest to go on to pursue this reading, there's a strong static assumption built in here because it's a stochastic process. We apply a strong stationary process in building in the model. Just one word of warning. But today, instead of going into details about particular machine learning technique, I want to bring up another issue that can be equally important and sometimes can be also sensational. So I want to talk about this why, which is the observation. So observation, normally we take out, from field studies, we go out, we see a bird, we measure the concentration of chemicals in the stream or in the soil, and we normally take it as granted. But should I? So if you look at the graphs here, I presented 4 graphs. At least in my eyes, I can see it appeared here where my cursor is moving. There's a triangle in the white color. And the lines here, cursor is moving. It's all zigzagging. If you look at the blue highlighted, the blue rows, which my cursor is moving, it's all zigzagging going this way. And this picture, if you look, you can see, what do you see in this picture? Can somebody help me? What you see in this picture? This one?
Young lady.
Cool, young lady. Anybody else see something else?
I see an old lady.
Yeah, see, I think, okay, I see both, depending on how you look at this problem, old lady or young lady. And the example here I gave in this white triangle, there's actually no line here. There's no white line here. And this zigzag line, actually, they are all parallel. And the most interesting, the last one, I think many of you are like me. I see a rotating 3D structure. Actually, this is nothing but a 2D painting. So what I want to pose a question here, or provoke some thinking process here is observation itself something we should question now? So that brings to the basic concept, from quantum mechanics. I think this is an experiment called the Schrödinger's cat. Has anybody heard about this Schrödinger's cat story? Yeah, who can explain a little bit? Who knows the story? Okay, so let me try. So you have a box, right? You have a box, and you call it Schrödinger's box. And Schrödinger is a guy who developed quantum mechanics. And he said, okay, I put this cat in the box. At the same time, I have a machine that can connect a vessel which contains super toxic gas. So if I do something with a handle that use a hammer to break this particular flask, then the toxic chemicals will come in here and kill the cat, right? So this is the process, all set up here with the water facilities. And this handle is triggered by the fact if I open the cover of the box. Now, the questions come in before I open the box. Is the cat live or is dead? So in other words, to make it more tangible, is before the observation, right? Before I open the box, which is the observation. Before I take the observation, this cat has certain state. It could be live or dead. But once I open the box, this cat can only exist in one state. It's either going to, if I open the box, I trigger the mechanic, I break the flask, the cat will die. So how do we reconcile this problem? It's actually called the Schrödinger's cat paradox. The paradox comes in that before we observe this particular phenomenon, which in other words, when the box was closed, the internal state is unknown. And the only moment we can know the state is through opening the box. But the action of opening the box already altered the original state. So that's happens so much in quantum mechanics. So I bring up quantum mechanics here is because so far based on our human knowledge, there's only true or uncontroversial physical theory that govern the operation of the whole universe is quantum mechanics. And if you look at the fundamental equation of quantum mechanics, it's all deterministic. However, the final output of quantum mechanics is probabilistic. So you see where I'm going, right? So in real geo and spatial modeling, many of the models are probabilistic. And the origin of the probabilistic outcome is through some probabilistic route or some deterministic route. So let's just look at a simple example. This is a very famous example from Laplace. He's saying this whole world will be determined. If we know the past, we can predict future. And many times we actually doing that. We predict the weather, we predict climate based on our knowledge and understanding of the past. But is that something so well grounded? Do we know enough about the past? If we know enough past, can we predict future? Let's put the one example here, a little far away from quantum mechanics. I think many of you study dynamic system. This is a very simple logistic equation here. It has been used in modeling population dynamics and in many other examples. You have seen here, based on the particular realization of this parameter, you can see the overall dynamic evolution can diverge at certain points. And this very interesting observations, this divergent point has certain mathematical features. This is totally non-quantum mechanical, it's totally classical. And this is even probably more familiar to many of you, is a Lorenzo phenomenon where he's trying to build some model for weather. And by that time, he was still using the punching card machine. And one time he forgot and let the machine keep going. Then when he came back, he tried to reproduce the result, and he couldn't. He observed this so-called chaotic behavior. So I just want to throw in all these examples to stimulate some probabilistic thoughts. You're welcome to chime in or stop me, interrupt me to input your opinions. So I just want to show here that there's a lot of things in the geospatial modeling that are very interesting, that are so interesting that the root is still unclear. Like the famous, Feynman said, if you think you understand something, actually you don't. Also, people are more confident, and they think in the psychological world, there's an existence of himself, and then comes reality. So this goes back to the three-word example I talk about: the psychological world, the physical world, and the mathematical world. And finally, Einstein said the problems of future cannot be solved from the level of the same level of consciousness where that problem has been created. So in today's ecological modeling, there are two big questions. One is about scaling. I think many of you are aware of it. The second one is uncertainty. Many people use the analogy to view these two problems as the two clouds when early days physics, the classical physical mention encounter the catastrophe, which moves the classical mechanics into quantum mechanics and the production of general relativity, which bring the physics in the new domain. Now I bring it up here to all of you guys as the future of our geomodeling. There's no Einstein yet in geomodeling. And there's an opportunity for you to look at these two questions and think deeply. And there's a great opportunity for you to make great contributions to this society. And the future of this human civilization and science lies on you. A little effort from your side may mean a great leap for human civilization. If you ask me how I understand this is, how I related what I talked a moment ago with machine learning and the quantum mechanics and uncertainty. So I think this is going to be a long-term converging process. Machine learning, which I'm labeled here, ML, is generally thinking different from human learning because the way we process data, we generate conclusions is quite different. And the difference lies in how we construct the machine learning models. As we progress in the future with the information theory, these two branches will merge together in the long run. But as a personal viewpoint, I'm happy to share with you. I'm happy to hear your opinions. So, okay, so all of this course about, I think Giuseppe already mentioned, this course is trying to offer a way to see things deeper and further. Basically give you an opportunity to gain insight into a matter of modeling. So what do I mean by that? So there's an example, a very famous example about the plant cross hibernation. So in this Mondale example, he basically crossed two kinds of pollens, which have different, controlled by different genes. So expressive become purple, is recessive become white. And he has done this experiment. He drew a diagram based on his theoretical calculations. He should observe the purple one about 75%, the white one about 25%. It's all theoretical. And let's see some numbers. And he has done experiment and he found 70.05 colored, white 224, theoretical expectation is 3 to 1, and his calculation is 3.147. So the question to you is, does Mondale's experiment support his general hypothesis of his diagram? Someone please say something. I hope I made the question clear, right? So if you look at diagram by this experiment, he should expect the outcome of this purple color, or the so-called colored, 3 out of 4, which is 75. The white one is 1 out of 4, is 25, right? Apparently the ratio is 3 to 1. But his observation is not exact 3 to 1, but close. What does it mean? How do we interpret this one statistically? Is his experiment close enough to support his hypothesis?
What do you need to arrive to 3 over 1? Or at least 33%. Anyone?
Come on, guys, say something.
We increase the number of points. What is our observation? What is happening? Is it going better or not? If you have a coin, say you flip one coin only 1 times, okay, you have only one coming. But if you flip more times, you have almost 50%. But if you keep going, then it's getting closer to the 50%. So it's the same concept.
But the coin is an independent experiment. The flowers, I'm not sure if they're independent because they're generations of the same.
Okay, perfect. We are going there. Longzhu,
Yeah,
what
thank
is
you so
your...
much, Juan, for the input. Yes, yeah. So the points, the coins toasting experiment, we normally treat them as independent events. So here we're talking about a sample space, an independent event, and the particular probability to observe an independent particular event. So I think you guys have done statistics already. This is basically binomial distribution in the coins flipping cases. But the example I'm showing here can be viewed as a approximated binomial distribution. Of course, in one particular experiment where Mondale did it, this particular setup ratio he has observed, it can be viewed as one-time coin flipping, because in the next time he can start breeding the plants separately for another group. So in general practice, we use binomial distribution to simulate a lot of ecological events. For example, in the species distribution model, the presence and the absence of a particular animal, we many times assume this a Bologna process, and they are not truly independent, but to some approximation, we treat it independently. It's an approximation, but there are other ways to treat it, to consider spatial correlation. So for example, what I'm trying to say here is, okay, you can treat it as one experiment, like flipping a coin. But the other thing you can do is you can do the hypothesis testing, which is coming from the statistical analysis, to tell you the deviation of a 3.147 is significant enough from 3.1 to reject or accept this hypothesis. So this is my point. So in many cases, we have to, especially in ecology, we do a lot of data collection, and we do the experiment and build models. In the process, we need hypothesis testing. It's a very important procedure in the overall model validation in many times, especially, for example, just a few examples, you do the logistic regression, you do the general linear regression. Many times you have to test the significance of the coefficient you arrive. Just a simple example to wake up everybody. So we're getting close to finish. This particular course is about principle. It's about thinking process. When you encounter problems, how do you think? How do you derive your models? We'll give you a lot of tools at your hands, and you will access them to the best of your capability and your situation. It's not about a recipe, it's about principle, how to think and how to model. It's not about number of problems you solved, it's just about how to solve the problems when the direction is unclear. So that's normally the high-level modeler would say, through the modeling experience, you can see the hidden links. You can see the connection that's appearing to be hidden, and through those connections, you can build better models. And through that, you can achieve the higher power of prediction. And the power is in your hand to make a better and brighter future for everyone. So that's why we built this course together. I hope you enjoy the freedom of the lens of mathematics and come out at a higher elevated level, looking at the spatial problems and the modeling. And in the end, thanks for your attention and your time, and entertain with the final drawing here. It's actually a presentation of pi, if you have interest to look into it. That's all about my presentation. Thanks, everyone. Should you have any questions or concerns, or to provide some input, please feel free to come to chat with us.
Thanks, Longzhu. Thanks, Longzhu, for this interesting talk. And this will be the fundamental that Longzhu is trying always to bring inside to the geography computation also, when we try to work together, and we're learning a lot from these fundamentals and then try to apply. So it's going to be also our task and your task, let's say, try to apply the fundamental that Longzhu is teaching inside to your field of application. So we will see several examples of mathematical modeling, probability theory, and mathematical theory also to apply to explain the machine learning behavior, and then the coding to see the machine learning implementation inside to the real application in geographical domain. So this one today was really to give you an overview of what we are going to cover and how we are going to structure the full course. Then along the path, we can also tuning a bit. We have more or less a clear path of the lectures. Some have been already developed and teach through the years, and some other they will be quite new. So we are also working in the developing new material. And for this, I want to bring once again your attention to the material that I send you by email, in particular for the installation of the virtual machine. So in this web page, the link that I send, you can find directly step by step how to install the virtual machine. So I also developed this OSGeo live installation YouTube video that is going to guide through. So you have all the explanation over here. Do it step by step. In this way, you will not encounter any problems. For people that were already asking me, for people that have already Linux installed, you can keep your installation, means that you are already advanced. So you can just focus on pre-installed some software from time to time. We are going to use GDAL, PK tools, GRASS, and some Conda for Python application. So based on this one, we will give the information how to install it, the notion how to install it, all the software before the classes. Rather, if you use it, the OSGeo Live will be a bit easier because you don't have to troubleshooting, let's say, for your personal installation. So if you have Ubuntu and maybe you are just in the beginning of using, so I still suggest you to install the OSGeo. Rather, if it's already maybe 1 year that you're using or even more, no problem. You can following along with your Linux. So over here, you can please pay attention to follow all the steps, and in particular also, like I shown you your video, pay attention if over here in your machine, during the installation is not coming out the 64-bit so is the 32-bit, is because your BIOS is not set for the virtualization. So you have to enter in the BIOS. So you can see in this web page there are several way how to enter. That one is very entering the BIOS is very PC specific, so it's changing from model to model. Sometimes it's Control F2 during the booting, and sometimes it's different. So it's really so try to see how you enter in the BIOS, and then you have to change the virtualization setting. But this is only if this one does not appear. Pay attention not to do overpassing the memory size, stay in the green area. Also having a computer with more than 8, from minimum of 8 gig more, if not you can encounter a problem. And then for the rest will be coming quite along, following this step in the video tutorial. In particular, in the end, when you finish, you should have the virtual machine completely pop up, okay? And you can follow later on with the update of your system. An update, this is quite long, it will take 5 minutes. Do not interrupt during the upgrade. Do not, be sure your power is also connected, because if during the update, this is a very tricky point. If you crash the system for any reason, for power missing or whatever, then you have to start from again. And also this one, pay attention to done properly, this one, the virtual machine, this the insert guest addition. This is very important for the enlargement of this window, so they go in full mode, and also for the copy paste operation. Anyway, again, if you follow the step, it should come quite straight. These last lines are for enriching the virtual machine with additional software and data. So people that they want inside Ubuntu, they can download the same script, opening, and they can see the few lines that they need to run also to to enrich the software with to enrich the OSGeo with the additional software, and also for the data that we are going to use it. And then in the end, there are some little tests, let's say, for the command, little tests for the command to see if everything has been working properly. There is also RStudio. We are not use it, but I like to we are not going to use it, but I like to install it in case you want to also get familiar with RStudio during your free time. Let's try to have the virtual machine running for next in 2 days, for Thursday. In this way, we can have a review, and we can have a review if everything is online, and eventually we can even starting the course. I mean, the course for the coding part. The first part is going to be focused on the use of Bash. And we are going to use it in particular. These two page is going to be really the basic of Bash, like change directory, list file, grep words and pattern inside files. So for the people already advanced, feel free to scrolling down and see if you want to follow or not, or you can just follow, stay in mute and do something else, and then pay attention if something pop up. So we are going to dedicate starting with this one, and if we are progress fast, we can reach also the second part of the path. And as I mentioned before, people in the beginning, please try to speed up, let's say, in order to be able to push forward everybody to high level of application. Yes, another point, I also invite most of you for the I think no, most of you, all of you, for the Slack channel. We are going to use it as Slack channel for our communication troubleshooting. I use it the email that was provided inside today. So this one, okay, I close it. But anyway, the one from your university, if you have your Slack channel with another email, please let me know that I will also add it, your personal email. in case you are not using, you have already Slack under the other email. That's it. So we can spend these few minutes also to talk a bit. If somebody has already done the OSGeo Live installation, and if has been coming soft, and yes or no, or start to, if you have questions and doubts about this.
Yeah, just a few comments related to my talks. I think you know, what I'm trying to do is trying to really stimulate your thinking process. And sometimes I bury some questions, and sometimes I bury some intentionally made mistakes, as you show in the examples. So it's always good to go through. Some of them intentionally made the opposite argument. So if you have questions, feel free to chat with me in the Slack channel. Especially some of you, I remember you talk about you study numerical analysis and dynamic system. I was still surprised that you were very quiet when I talk about the problems in my talk. So if there's something you feel doesn't make sense, or you realize a mistake I intentionally made, let me know. So you can, yeah, we can always chat. There's I think there's a very famous teacher in his class in USA. His students were very good. Many of them got Nobel Prize, and he's famous for his lecture note to be messy. And sometimes he had mistakes on the blackboard. And by the time the course was finished, the students have to go through everything and work out the derivation by themselves. And by the time then they finish, they become on top of the material by themselves. So I hope you can go through the same process and scrutinize everything I said and everything I told. If you find you know, your independent thinking, and that's my best hope, because eventually it's going to be you to make a decision in your trajectory of career and building models. So yeah, that's what I'll say. I hope you always look at the problems with a suspicious mindset and try to build your habit of independent thinking. That's it.
Thanks, Longzhu. Coming back to our installation procedure, any one of you have already tried where it is with the OSGeo Live installation? I know that Alex was trying, but she's using already Ubuntu, so probably, how long have you been using Ubuntu, Alex?
For almost 5 years now.
Sorry?
Almost 5 years now. Sorry, I'm using
5 years. Yeah, perfect. So people with the good experience, they can just install the software as they need and going along. Somebody else have been trying?
I have installed the Oracle virtual machine and
VirtualBox.
So, yeah, the toolbox and everything. I set up the virtual machine.
Okay, perfect.
I didn't test through, like I didn't go through the testing part, but it launched and was looking fine.
Perfect. Yeah. Yeah, the downloading, the update of the software take a while, so take like half an hour more or less. So be ready to do something else meanwhile. Yeah. Anyone else has been trying?
Yes.
Alexandra?
So oh, sorry. Go first.
Yeah, you can go.
Okay, yeah, so I've been using OSGeo for some time, and I have come across a problem from the graphical user interface that sometimes the taskbar on the bottom is not there, and then I have to turn it off and on several times, and then it works again. But sometimes it's just not there, and I don't know why. I think you're muted.
Giuseppe, are you talking? Are you speaking? We don't hear you.
Sorry. Sorry, yeah, I think Julia, you were mentioned about this bar over here.
Yes, yes, yeah. It's not critical, but sometimes it's just not there.
Yeah, I would say that probably all these, let's say, graphical user issues, and also in the full screen, and or you cannot enlarge it, most of them are due to this step. So the VirtualBox addition add-on. So try to do it carefully, this step, and probably also that one will improve, because also this one can be due also to the resolution and so on. So all this part of graphical issues can be solved by the VirtualBox addition, yeah, guest addition VirtualBox. Any one of you use Mac? One, two, maybe two or three or something like this. Yes, so for Mac people also, you can install VirtualBox, and you can also through the time slowly migrate, let's say, make installation for inside your Mac and use it, your Mac terminal that is very close to the Linux one, and for the computation. There are problems with PK tools. We never be able to solve it for the installation. So that one I know GDAL, there are binary for Mac, but for PK tools it's quite difficult. I'm not neither a Mac user, so I didn't spend so much try in compiling and so on, but I know that is a bit painful. Rather for the rest, they can do it an easy, let's say, an easy life for the installation. So we will spend the next tutorial, next lecture in go through the installation step by step, and at least asking, but more you do it, better it is, let's say. And also you can start already using the Slack to see if there are people using the Slack, if there are people with the same issues, and try to solving among us. It's very important that we build up community for troubleshooting. As you know, you spend a lot of time. So and especially with the fact that we will have a machine that is the same for all of us, that will be a beauty, because the same problem can be solved by one person and then reflect the saving of time of everybody. Okay, I leave it to you the microphone for some question in case you have for these last minutes that we have. Anyone want to say something, adding?
Yeah, I have just one question about the, well, I installed this VirtualBox, and I think I managed to install OSGeo Live and update everything. But then when I run the bash terminal, my keyboard does not seem to be working properly. Like some of the symbols are not corresponding to the ones on my keyboard.
So over here, yeah, good question. Over here, yes, so you should have United States, the default.
Mm-hmm.
Okay, so if you do right click on that one, you can setting up right click or just a click. You can setting up your keyboards in according to the PC that you have. You can select your language. Okay, so that one is the first stuff that you have to do, and be careful, because sometimes people click it and does not realize, and they select another language. So you can even make constant, so delete all the other language and just leave it the one for your for that is in agreement with your keyboards. Mainly for coding, maybe, okay, through the time is always useful to have English, let's say United States keyboards, because you have the tilde, you have you know, all the symbol for coding that are a bit more directly, rather for some keyboard that you have to combine the combination. Also the curly brackets is a bit easier. I'm Italian, but I'm also using the United States keyboards. So I use it. I find it quite easier to use it for coding, mainly for coding. Okay, very good. Somebody else? Some other issues?
Just to jump in, the British keyboard is pretty good also.
I think they are very similar, UK and US, no?
Well, no, you have a British pound.
Okay. Somebody else, some other issues?
I installed.
Oh, sorry, go ahead.
No, thank you. I installed the VirtualBox on Mac OS. I mean, it seems to be straightforward, so I was not sure whether that's something wrong. And so when I open it, I can see the VirtualBox and it says click, double click, so I did that. But then number 2, it says run the VirtualBox application from applications folder. So when I click, maybe I need a mouse, is that correct?
So what do you mean over here? Biodirectional, no?
Well, when I open the VirtualBox, the symbol looks like USB. When I open it, I get one double click on this box. I've done that, so I've done that to install it, and then installation was successful. And then there is another option, number 2, which says run the VirtualBox application.
Okay, maybe you can share your screen. I can have a look.
Okay. Yeah. Yeah, so that's the
perfect. So you can yes, there is a slight different. Yeah, so you can you can run the VirtualBox application folder. Yeah, if you click that one.
Maybe I need the right click. Is that no? I just
twice. Okay, it should be somewhere there. Yeah, if you click there.
Twice, yeah.
Yes, it should be down, maybe scrolling down, there should be, yeah, VirtualBox there. Yeah, the other one, yeah. Yeah. So that one now, perfect. Now, if you run that one, yes, now you can follow the procedure like is in the web.
Okay, yeah, thank you.
Perfect, yeah. Thank you. Somebody else, maybe, yes, good to, if you're sharing already this problem, because we can speed up the process.
I've got a question about like the recordings. Are all lectures going to be recorded? Because I've got another course starting next week that's scheduled roughly for the almost exact same time as this one.
Yeah, so all the lectures they are going to be recording, and we are going to put the link as soon as finished in the web page. And I will create a web page straight directly over here, let's say in the beginning, with all the link. In this way, you guys can follow. It's recording it automatically, so we will have also the break, because I tried always to start with another system, but then sometimes we forgot, so they are truncated. So when we have the break, you just go through and process fast and so on.
Okay, good, because then I can do this course. Otherwise, I would have had some issues.
Good.
I have a question regarding there's a line in this cookbook which says you can check if your shared folder is correctly set up. And when I type in that command to the bash script, so that ls home/south/.
Sorry. Okay, this is my typo. Okay, I already find the typo. This one is user. Sorry.
Yeah. Okay.
Yeah. Sorry, my mistake over here. I will change it. This one at home. Come back in 20 minutes, and you will see the right path.
All right. Great. Thank you.
Come. Anyone else? Okay. So we can resume for next time. See you in Slack, and I will fix this problem, and you can go through the all the different steps and so on. Okay, we will try to join always 10 minutes in advance for checking microphone and so on, and sharing folder, and then also for some free chat and so on, and sometimes even